So this is problem 48 of chapter 4 of Giancoli 6th edition. So we have two crates. I'll be calling them boxes. They have different masses and they're in contact. So I'm going to draw here the box that has mass M1. It is touching this other box M2. I'm putting them separated like this so I can draw all the forces, but they are touching each other. If they are at rest on a horizontal surface. Okay, so this is the surface. Okay. And then finally we come and exert a force on box M1. So we have here this force, I'll call it FP, that we exert on box M1. And then the boxes will start moving. And this is a more realistic problem. There is friction, so we'll have to take into account friction force. Okay, so since they will be moving, what will be given to us is the coefficient of kinetic friction. Okay? All right, so let's draw all the forces because we want to solve the problem. The first question of this problem, question A, is what is the acceleration of this whole system? Okay, so let's start from box 1. So we have that force acting on box M1. Box M1 is also touching box M2, so it exerts a force on box M2. I'll call it force C, and M2 reacts and exerts the same force on box 1, just opposite direction. What else do we have along the x-axis in box M1? As we said, there is friction. So we have to take into account friction. Friction is parallel to the surface and it's opposite to the motion. Since the motion is going to go to the right, the friction is then to the left. And I'll call it friction 1 because this is the friction force with respect to box 1. How about box 2? Well, in addition to that force of contact with box 1, this one also has friction. So I'll call it force of friction. And to differentiate from the box 1, I'll call it force of friction of box 2. So these are all the forces along the x direction. How about the forces in the y direction? Well, both boxes have weight. So I have here M1G. For this one I have M2G. We are touching the surface, so there is contact. There is no more normal force. Normal force is always perpendicular to the surface. So here I have the normal force of box 1, and here I have the normal force of box 2. Okay, so it's important to put these indexes to differentiate the two boxes. Okay, so now I have all the forces. Let me choose a frame. I'm going to choose that to the right is positive and that up is positive. Alright, so let me start writing all the equations for box 1, crate 1. And let me start with the forces along the x direction. So what do I have? I have Fp, which is positive. I have Fc, which is negative. And I have also the force of friction, which is negative. This box is going to be moving to the right, so A is positive. And I'm going to put here M1A. How about in the y direction? In the y direction, we have just Fn, and this is Fn1, minus M1G. Along the y direction, there is no motion, and this is then 0. So this is important because from here I can get what is Fn1, and Fn1 is just M1G. Why is this important? Because I need to find the force of friction. I know that the force of friction is the coefficient of kinetic friction, so mu k, kinetic friction, multiplied by Fn1. And Fn1, we found it here. Okay. So let me rewrite this equation. So here I'm done. Yeah. Let me rewrite the equation for box 1 in the x direction now with everything that we have. So we have Fp. The contact force I do not know. The friction force we do know is that mu and Fn is m1 g, m1. Okay, so what we have to find in the problem, this case, do I have everything here? Well, I have the mass, yes, it's given, g I have, the coefficient of kinetic friction is given, Fp is also given. My problem here that prevents me from solving this problem with just this equation is the force of contact. So what I'm going to do is I'm going to go to box B. Okay, so let's go to box B. Put all the equations also for box B, box 2. So in the x direction, what do we have? Here we have just the contact force, and that's it. In the positive direction, that's it. And we have the friction force trying to oppose the motion. This is the friction force on box 2, and it's going to move to the right. Acceleration is positive, and I have m2a. Again, same thing, I have to find this friction force. This friction force on box 2 is the coefficient of kinetic friction multiplied by the normal force of box 2. Where do I find the normal force of box 2? In the equation along the y direction. There I have Fn2 minus m2g equals to 0. There is no motion in the y direction. And from here we get Fn2, which is equal to m2g. Okay, so this I'm going to use to find the friction force. Let me put now everything together for the box 2. So for the box 2, I have the force of contact minus the friction. The friction is mu k Fn, which is m2g, equals to m2a. Again, I want to find a. From this equation, I'm in trouble because I don't have x. Okay, but what we have now, we have two equations and two unknowns, and so I can solve this problem. So I'm going to isolate Fc from this equation, from the box x. So I see that Fc is mu k m2g plus m2a. I put this in this equation, and now I can find a. So now everything is known in this problem. We can find a. Once we have a, we can go to the second question of this problem, which is, what is this contact force? What is the force that one both exerts on the other? We can use, for example, this equation here, since we will have found a already. Use this equation to find the contact